delta is an element of 1 or epsilon over 5. Okay. So what we're going to do is we've got two cases. Okay, we have case 1. So now we have case case 1. It's when delta is chosen to be equal to 1. And let's see what happens there. So now what we're going to do is now we're going to proceed with our proof. Okay. So we've just found the deltas. Okay, we've got two deltas. Okay, so let's now take this particular fact, the premise, and see can we infer this thing over here. See can we infer this particular conclusion. Okay, so what we have is this is that we have, excuse me, we have that x plus, let's take case 1. So we have that, let me just go back here. So we're choosing now delta is equal to 1. And what we need to show is we need to show that 0 less than the absolute value of x minus 1, which is less than delta, that implies that x squared plus 2x minus 5 minus 2, the limit, okay, is less than epsilon. So we need to show this particular fact, okay? So let's do that. So what we have now is this, is that we know when we choose delta is equal to 1, okay? So therefore, we have that x minus 1, the absolute value of x minus 1 needs to be less than 1, okay? Now, in our previous definition here, you could see that what we found to be less than epsilon was the absolute value of x minus 1 times the absolute value of x plus 3, okay? So what we will know now is this, is that, and we know that the absolute value of x plus 3 is actually a positive number because under this particular restriction, it's actually greater than 3 and it's less than 5. Okay, so we can actually multiply both sides here by the absolute value of x plus 3. So this implies, okay, so now what we have here is that this implies that we have the absolute value of x minus 1 times the absolute value of x plus 3 must be less than 1 times the absolute value of x plus 3. So we just multiply both sides by x plus 3. So what does this tell us? This tells us that the absolute value of x minus 1 times the absolute value of x plus 3, okay, must be less than the absolute value of x plus 3. Okay? Now multiplying out these brackets here, this tells us, so this implies that, which implies, so now what we have, this implies that x squared plus 2x minus 3 is less than the absolute value of x plus 3, which implies that x squared plus 2x, we have to get this, don't forget, we have to get this in the form uh, of uh, f of x minus L. Okay, so we really need x, the f of x, which is x squared plus 2x minus 5. So let's just put that in here. X squared plus 2x minus 5. Well, this isn't that, okay? But if you see, if we add on plus 2, okay, to this, okay, what we do get is this particular quadratic here. So really what we've done, we've expanded the minus 3 out into a minus 5 and a plus 2. We've taken the limit that we require out of there, okay, which is less than the absolute value of x plus 3. What does this imply? This implies that x squared plus 2x minus 5 minus 2, okay, must be less than x plus 3. Okay. But we already know what x plus 3 is. Okay, so x plus 3, if that makes sense, excuse me, we know that x plus 3 is less than or equal to 5. Let's actually just take this fact here. Okay, so because we chose the minimum, okay, so we chose the minimum here. This is, let's say, the min, okay, between 1 and epsilon over 5, okay. So note, okay, because this is the min between these two, what we now know is that 1 is less than epsilon over 5, and therefore 5 is less than epsilon. But we know that x plus 3 is less than 5. So what does this imply? Well, this implies that x squared plus 2x minus 5 minus 2 is less than, well, x plus 3 is less than 5, okay? So x plus 3 is actually less than 5, okay? Which is in fact less than epsilon, which is of the form that we require. That's exactly f of x minus L is less than epsilon. So going from this fact here, which is x minus a is less than delta, okay, choosing delta to be 1, what we've deduced is that f of x minus L is actually in fact, okay, less than epsilon. And that's the first case, okay? So that's the first case that we have. So there is our x minus a is less than our delta. So let's choose the second case, and this is probably a little bit more straightforward. The epsilon, let's choose the epsilon over 5, okay? So let's say case 2. So now we have case 2 when delta is equal to epsilon over 5. So once again, we need to take our premise. We need to show that when the absolute value of x minus 1 is greater than 0, this is the x minus a is less than delta, that implies that the f of x minus L, that the x squared plus 2x minus 5